Welcome students. So today we are going to go to the next method of factorization of factoring a method, factoring a number. Last time we have done Fermat's factorization method. That I have shown you two ways in which you can do factorization of a number. So in this method, second method for factorization is nothing but pollard P-1 factoring algorithm or pollard P-1 factorization. Okay, in your pollard P-1 factorization, okay, when you do a pollard P-1 factorization, you will get a prime factor, okay, one of the prime factor of the number of which you are calculating the factorization, of which you are the number of which you are factoring. One of the number that you are going to get of that number will be nothing but a prime number. Okay, for example, okay, now if we take an example, for example 391. So 391 is a number n of which you need to calculate the factors. Okay, so one of factors of it will be a prime number. For example, now usually 391 is having factors as 17. Okay, they are having two factors. One is 17 and 23. So one of the condition over here is nothing but one of the factors. Okay, when you are calculating. Okay, now 23 is also a prime over here, but the condition for polar P-1 is when you are calculating or when you are factorizing any number, one of the factor, okay, of your polar P-1 will be definitely a prime number. In this case, it is both prime numbers, but minimum requirement is one of the factor will be a prime number. For that, we require a value called as bound value B. Okay, for this method we require a bound value B. So it is a bound value such that your P, okay, is nothing but your P is nothing but the prime number should equal to GCD of 2 raised to B factorial minus 1 comma n. So whatever you are getting over here at 2 raised to B factorial minus 1 comma n will be stored as P. So as of now, you don't need to go into deep of what is that B, what is this formula. Okay, so you don't need to go. Just keep in mind pollard P-1 finds out the factor of a given number, out of which one of the number okay, will be definitely a prime number. Okay, and we require a value called as B, which is a bound value. So in your problem, what will be provided to you is nothing but n will be given to you, of which you need to find out the factors. Okay, so n will be provided to you and this B value bound will be provided to you. So both this value will be provided to you and you will be told to find out the factoring. So the moment you have B into the problem, okay, the moment the bound value is given to you, you should understand that we have to solve the problem using pollard P-1 algorithm. Okay, so just keep this in mind. The moment there is a B in the problem, okay, where the number is given to you to factorize using B, okay, that means you have to use pollard P-1. Okay, now in your textbook there is one algorithm which is very complex and complicated algorithm. Even if you read it 2 or 3 times, you won't be able to understand how to calculate the factors of a given number. Okay, so I have found out very simple algorithm, okay, of pollard P-1 factorization. Okay, so just wherever I'm explaining now, just go through the algorithm properly, because we have to use this algorithm to solve a problem. Definitely we are going to track this algorithm using a problem, but you should know the algorithm first. Okay, so this algorithm is known as pollard P-1 factorization n comma B. You know what is n? N is the number of which you need to find out the factor. Okay, and B is nothing but bound, which I have already explained it to you. Okay, so n is the number of which you need to find out the factor and B is the bound. Now your algorithm or your code starts. Okay, so initially, so this will be your step 1. I will write here, this will be your step 1. Okay, so initially in step 1 you have to always consider A equals 2 and E equals 2. Okay, irrespective, there are some formulas to calculate A and E. A should be nothing but any number greater than 1. Okay, and E should be also a number greater than 1, but usually we take the value of A and E as 2. So for any problem of polar P-1, take the value of A as 2 initially and the value of E as 2. So that is your step number 1. Okay, now your step number 2. What is your step number 2? Your step number 2 is nothing but this. Now this step number 2 will be your iterations. Okay, there will be various iterations for this step number 2. Okay, so while E less than equal to B, so initial value of E will be taken as 2 and B will be provided to you. So until and unless this particular E is less than equal to B, you have to repeat this while loop. Okay, what we have to do in this while loop? Okay, so while E is less than equal to B, you have to calculate the new value of A. Initially we have taken the value of A as 2. So now we have to calculate the new value of A using formula A raised to E mod of n. Okay, so what is A? A is nothing but 2. E will be initially also 2. So 2 raised to 2 mod of n, whatever is the formula, and new value of A you need to store over here. Once the moment you store the new value of A, I need to increment the value of A. So initially E was 2. So now 2 plus 1 will be equal to 3. So for my next iteration, so while it will be 2 less than equal to B, okay, and new value of A, whenever we are taking this A, I have to take the new value of A which we have calculated in the previous loop, okay. So this loop is going to repeat, unless and until this condition is not satisfied, okay. Don't need to get confused. You will clearly know how to calculate it when you are actually solving a problem, okay. Now your step number 3 is nothing but this. I need to calculate the GCD of A minus 1 comma n, okay. So step number 3 is this, GCD of A minus 1 comma n. So, and store it in the value P. Okay. Now step number 4 is this. Okay. Now your step number 4 is this. In step number 4, what are you doing? So step number 4, if your P value lies in between 1 and n. So if your P values is less than 1 and greater than n, then I'm going to in between this buffer, then I'm going to return this P. Okay. Then I'm going to return this P. Okay. And then I'm going to find out the factors of n. How I will calculate factors of n is nothing but your n will be nothing but, okay, one factor that we have already calculated, that is P, multiplied by another factor, that will be y. We need to calculate this. So we have the value of n with us, we have the value of P with us, which is one of the prime factor which has been calculated using polar P minus 1. I can easily calculate what is the value of y. Okay, so if your P, please pay attention here in step number 4, if your P lies in between 1 and n, so it should not be less than 1, okay, it should not be 1 or less, it should not be less than 1, or it should not exceed value of n. We have to return P. If your P does not satisfy this equation, if your P is less than 1, okay, if your P is less than 1 and if your P is greater than your n, then we have to return failure. So this is nothing but your step number 5. Okay, if it is not 1, okay, if it is less than 1 and greater than n, okay, then we have to return failure. So that means we cannot find out the factor, okay, using this particular algorithm. So that is a shortcoming of this polar P minus 1 algorithm. Okay, using polar P minus 1, we cannot find out the factors of all the number. Please keep this in mind. Okay, so using polar P minus 1, you cannot find out the factors of all the numbers. So always keep that in mind. So to find out the factors of the number, okay, we have to, using this method is not possible to find out for all. So in your problems that will be provided to you, okay, so you have to first go through all this algorithm, okay. So go through all this algorithm, find out. If you are not satisfying step number 1, then you have to directly come and say that the algorithm is a failure. Okay, so we have to follow that when we are solving the problem. Usually the problems that are given to you in your exams, okay, you will find out what is the factors. Definitely you will find out what are the two factors. There's no doubt in that. But I'm just telling you in general that this algorithm basically does not find out, okay, for all numbers the factors of all the numbers. Okay, so we'll solve few problems. So with that, this algorithm will be very much clear to you. So just keep in mind polar P minus 1 factorization n minus b. This algorithm is very important. Okay, without this algorithm you won't be able to solve the problem. Okay, so next we will solve one problem and we will see how actually this algorithm is implemented. We will take this example only where n equals 391, okay, and the value of b equals 8. Okay, the bound value is given as 8 and n value is given as 391. We will see how to solve the problem, how to find out the factors of number 391. Okay, so we have taken a problem where your value of n, okay, of which you need to find out the factor is 391. The bound value we have taken it as 8. Okay, so let us start with step number 1. Okay, so step number 1, okay, in your algorithm, if you have noted the algorithm properly, I need to find out what is the value of a. So initially the value of a is taken as 2 and also the value of e is taken as 2. Okay, so now in my step number 2, my step number 2 is a iteration now. Okay, correct. My step number 2 is a while loop, which is iteration. So I am naming it as iteration 1. So what is the formula over there? While, okay, the formula is nothing but while your e is less than equal to n. So while your e less than equal to your b value, I have to continue this loop. Okay, I have to continue this loop. So while e is less than equal to b, what I'm going to do now? So my first iteration will be while, okay, my first iteration will be while, okay, so while my first iteration is E value, initially the E value is taken as 2, so 2 less than equal to B. B value will remain constant, that we have taken from here, that's given to us in the problem. So what we have to do now, while 2, definitely 2 is less than equal to 8, so I have to go into the loop. Into the loop, I need to find out the value of A, so A will be nothing but A raised to E mod of n, A raised to E mod of n. Okay, A raised to E mod of n, and then what is second step? E will be equal to E plus 1. I am writing this only for my first iteration, just so that you understand what we need to do in the iteration. In my further iterations, I am not going to write down the formula. So over here, so we need to calculate this. So what will your A become? Your new value of A, your initially value of A is taken as 2. So 2 raised to E, okay, E value is taken as E raised to, so 2 raised to 2. So over here I'll write down what is it, okay, so mod of n, and E value will be nothing but E plus 1, okay, we'll end this loop, okay. So while 2 is less than equal to 8, so A value will be equal to, A value is taken as 2, okay, E value is also taken as 2, mod of n. You know what is mod of n? N is nothing but 391. What is 2 raised to 2? 2 raised to 2 is 4. 4 mod of 391 will be what? Every smaller number mod of greater number will always remain as a smaller number. So answer will be equal to 4. So now the new value of A is nothing but 4. Now what will be the new value of E? Initial value of E is 2 plus 1, which will be equal to 3. So new value of 3, E will be equal to 3. So we have done with iteration 1. Okay. So again I will do step number 2 only, because until my while loop is completed I cannot go out of it. Okay. So my iteration 2 will be equal to for okay, now I'll not write down the formula, I'll direct write down. So this will be for while, what is the new value of E now? E value is 3, 3 less than equal to 8, so 3 is definitely less than equal to 8, so I need to calculate the new value of A. Formula is nothing but A raised to E. What is the new value of A now? Now I cannot take a older value of A over here, so new value of A is nothing but 4, okay, so that I will take over here. 4 raised to E. What is the new value of E? 4 raised to E is nothing but 3 value. Okay, that we have taken from here, new value of E. So 4 raised to 3, mod of 391. So this will remain common. Okay, mod of 391. What is 4 raised to 3? 4 raised to 3 is nothing but 64. 64 mod of 391 will always remain as 64. Any smaller number, mod of greater number will be equal to smaller number. So I have calculated a new value of A. Now E will be equal to E plus 1. What is the value of E now? 3. So 3 plus 1 will be equal to 4. So new value of E is nothing but 4 now. Okay. So I go to again step number 3. Step number 3, which is again my iteration 3, because my while loop have not finished as of now. So iteration 3. So what is iteration? That is nothing but while. Okay. So my iteration is nothing but while. What is the new value of the E? 4 less than equal to B. B value is 8. What I need to do, I calculate the new value of A. A will be nothing but, new value of A is what now? 64. 64 is to E. What is the new value of E now? New value of E is nothing but 4. So 64 raised to 4 mod of 391. N is nothing but 391. Okay, 64 raised to 4 mod of 391. What is 64 raised to 4 mod of 391? So when I calculate it on the calculator, I have got it as 16777. 216. Please do these calculations. Okay, mod of 391. So when I calculate this, okay, 16777 216 divided by 391. When I divide it, I get the answer as 188. I get the answer over here as 188. So the new value of A is nothing but 188 in my third iteration. Okay, and E will be nothing but E is nothing but E plus 1. What was E over here? The E was 4. So 4 plus 1. My new value of E is nothing but 5. Okay, my new value of E is nothing but 5. Okay, so now again my while loop is not finished. I go to step number 4. This is not step number 3, this is step number 2 only, because my iteration is not finished. So again step number 2, iteration number 4. Okay, step number 2, I will take iteration 4. Okay, iteration 4. Okay, so for this iteration 4, what I am going to calculate, it will be while, okay, E less than. So what is the new value of E now? The new value of E is nothing but this 5. Okay, the new value of E is nothing but this 5. So I am going to calculate here now for E value 5 less than equal to N. N is less than equal to B. B is nothing but 8. Okay, so my new value of E is 5. So what I am going to calculate over here, value of A. A will be nothing but A raised to E. What is the new value of A that we have calculated? The new value of A that we have calculated is nothing but 188. So 188 raised to E. What is the new value of E that we have calculated? 5. Okay, that also It is mentioned over here, okay? Or you can look over here, you will get what is the new value of E that is given. So to 188 raised to 5, okay, mod of 188 raised to 5 mod of 391, okay? So mod of 391. So 188 raised to 5, when I calculate it on the calculator, I get the value as a very big value. You can use modular exponentiation also to solve this problem. Okay, so I get a value 234849. Okay, 234849. 287168. 287168 mod of, please check when you are solving this problem again, please check whether you are getting this answer only. Mod of 391, mod of 391. Okay, when I solve this problem, I get the answer as 35. I get the answer as 35. So my new value of A is 35 and E is nothing but E plus 1. So that is nothing but 5 plus 1, which will be equal to 6. Okay, again I am doing step number 2 because my while loop has not finished as of now. So this will be my iteration 5. Okay, this will be my iteration 5. While E is less than equal to, so while E value is nothing but, now my new value of E is 6. Okay, I am calculating A again. A will be equal to A raised to E. What is my new value of A? My new value of A is nothing but 35. 35 raised to 6. E is nothing but 6. 35 raised to 6 mod of, okay, 391. It is a little simple to solve. 35 raised to 6 I got on the calculator as 188, okay, 1838 265625. 265625. Please solve and check whether you are getting correct answer. Okay, mod of 391. When I divide this, okay, using 391, what I am getting answer as 239. Okay, I am getting the answer as 239. So my new value of A is 239 and E is E plus 1, that is nothing but 6 plus 1, which will be equal to 7. New value of E will be equal to 7. So now I again do step number 2. I do my iteration 6 now. I do my iteration 6. So my iteration 6 will be for while, okay, while my new value of E is 7. 7 less than equal to 8. Yes, 7 is definitely less than equal to 8. I need to calculate the value of A. Okay, where A is nothing but my A raised to E. My new value of A is 239. Okay, my new value of A is 239. So 239 the whole, okay, 239, okay, 239, okay, the whole raised to E. What is the value of E now? A value of E is 7. E of 7 is mod of, okay, mod of 391. So now this is little difficult. I cannot calculate this 239 raised to 7 on calculator. It is a very bigger number. Till now, whatever we have done for till iteration 5, it was giving me a value. Okay, so I would be easily able to do a mod of that particular value. But 239 raised to 7, it is not giving you the output. It won't give you output on the calculator. So what we have to do now, use modular exponentiation. So over here we have to use modular exponentiation. Okay, modular exponentiation. Okay, so when we use modular exponentiation, I want you all to find out the value of it, okay, and tell me what is the value of 239 raised to 7 mod of 391. Okay, so I can give you a hint how I will divide my 239. So it will be 239 raised to 1 into 239 raised to 2 into 239 raised to 4 mod of 391. So you need to find out separately what is 239 raised to 1 mod of 2, then 2 raised to 239 raised to 2, and then this 3 values you need to calculate. Then multiply all the 3 values and calculate again the mod of 391 and tell me what is the answer. We will wait here until and unless you give me the answer of what is 239 raised to 7 mod of 391, then only we will continue the further problem. So therefore when we do 239 mod of 391, always smaller number mod of greater number will always remain as 239 only. Okay, then what is 239 square mod of 391 is nothing but it will give you answer as 35. Okay, so 239 square mod of 391 is 35 and 239 is 4 mod of 391, your answer will be you will get the answer as 52. Okay, you will get the answer as 52. So when you get this, you have to do again mod of, okay, mod 391. Again you have to do mod of 391. So when I multiply 239 into 35 into 52, I get the answer as 434,980. Okay, so 434,980. 980 mod of 391. So when I calculate this, very simple to calculate. When I calculate this, I get the answer of A as 188. Okay, I get the answer of A as 180. And what will be the value of E? My value of E will be nothing but 7 plus 1. So earlier value of E was 7, okay, as mentioned over here. So new value will be 7 plus 1, which will be equal to 8, okay. So again, I cannot finish this because my loop has not finished. So now again I will do my step number 2 only, but now it will be iteration 7, okay, iteration 7. So in iteration 7, what I am checking, while my E value, E less than equal to B value is 8. Now henceforth we cannot do because my next value will be what? Next value of E will be 9. Now 9 is not less than equal to 8. 9 is always greater than equal to 8. So this will be my last iteration in step number 2. We should identify that. Now let me find out the value of A. A is nothing but A raised to E. What is the new value of A? New value of A is 188. New value of A is 188. 188 raised to E. What is the new value of E now? 8. Correct? New value of E is nothing but 8. 2 raised to 8 mod of, okay, so it will be 188 raised to 8 mod of 391. Okay, so now again we have to use modular exponentiation over here. Okay, 188 raised to 8. So to find out 188 raised to 8, I need to first calculate what is 188 raised to 1. Okay, then I need to calculate 188 raised to 1 definitely. Then I need to calculate 188 square. Okay, then I need to calculate 188 raised to 4, and then I need to calculate 188 raised to 8. Okay, and now I won't be able to, I won't multiply this and this to 391 because I require only 188 raised to 8. So but I require to calculate this value so that I can find out what is 188 raised to 8. Okay, so tell me what is 188 raised to 8 mod of 391. Okay, and then we will continue further with our next step. So 188 raised to 1 mod of 391, we get it as 188 only. Okay, the 188 raised to 2 mod of 381, okay, 391, we will get the value as 154. Okay, 154. Then 188 raised to 4, we are getting the value as 256. Okay, 256. Okay, and 188 raised to 8, we are getting the value as 188 raised to 8 mod of 391. We are getting the value as 239. Okay, 188 we are getting value as 239. Okay, 239. So when we solve this 188 raised to 8 mod of 91, we get the value of A as, so new value of A will be nothing but 239. I hope all of you are getting this value. A was 239. Now I cannot go further, correct? Now what will be my E value? E will be E plus 1. E is now already 8. 8 plus 1 is nothing but 9. Now I cannot go to the loop again. My iterations have finished. So I have to go to step number 3. So what is my step number 3? Okay, what is my step number 3? My step number 3 is nothing but, okay, my step 3 I will write it over here. So my step 3 will be nothing but, okay, my step 3 is to calculate P, which is nothing but GCD of, okay, A minus 1 comma N. Okay, GCD of A minus 1 comma N. So in my expression, what is my GCD of A? A is nothing but a latest value, that is nothing but 239. So GCD of 239 minus 1 is what? 239 minus 1 is 238. 238 comma what is the value of N? N is nothing but 391. I need to calculate this value, okay, of P first. Okay, step number 3 is just to calculate the value of P. Okay, so I will calculate the value of P. I will show you how we calculate the value, how we take the GCD. It is very simple. What we are going to do, we are just going to calculate the GCD of 238,391 using Euclid's algorithm. Okay, so how do we calculate that using Euclid's algorithm? I will do it over here. So it's very simple. So let me just line over here so that there is no confusion. Okay, so I'm continuing here with step number 3. I'm continuing here with step number 3. Okay, my step number 3. So using Euclid's algorithm, when I calculate, I find out, so 391 equals 238 into 1 plus 153. Okay, so this is 238 equals 153 into 1 plus 85. Okay, so 153 equals 85 into 1 plus 68. Okay, please do this calculations. I have already done this. I am making it more simpler so that you will be able to solve the other problems. Okay, so it will be 68 into 1 plus 17. Okay, so now 68 equals 17 into 4, which is remainder is 0. So my GCD is Therefore, okay, okay, I'll write it over here. Therefore, GCD of, which is nothing but P, GCD of 238, 391 equals 17. Okay, so the moment it is equal to 17, what we do now? Okay, so this 17 is always, the condition is what now? What should be your P? Your P should be in between this, correct? Is it like now? What is your P over here? Your P is nothing but 17. So 17 is definitely greater than 1, and it is always less than your 391. So what I'm going to do now, the moment I get this value of P, so if I had got the value of P, or if I have got the value of P which is less than 1 and greater than 391, I will discard it straightforward. I cannot find out what are the two factors, okay? But now I'm getting it over here. So what I need to do now? So what I need to do now, my step number 4 will be equal to, to find out the factors. Okay, so my step number 4 will be equal to find out the factors. Okay, so how do I find out the factors? So step number 4, I need to find the factors. Okay, find the other factor. Now whatever you have got over here is one factor. Okay, whatever you have got over here, 17, is nothing but one of the factor. Okay, one factor, okay, of 391. Okay, one factor of 391, and it is a prime number. Just see, according to the algorithm, what was given according to the algorithm, using polar P minus 1, we are finding the factors of a number, given number, and one of the number out of that will be a prime number. So we are using this polar P minus 1, we have calculated 17, which is nothing but a prime number. Now we have one factor. Okay, we need to calculate the second factor. How we will calculate second factor? Okay, then your value, okay, over here, what will be the value? So your main is nothing but n is nothing but x into y. Now I've got the value of x over here, that is nothing but 17, one of the factor. This x can be written as p. Okay, what you have got it over here, p is nothing but one of the factor. So n is nothing but 391, okay, which is given to us. One factor we have already calculated as 17. Okay, another factor is y, which we need to calculate. Therefore, y will be equal to 391 divided by 17. Answer is 23. Okay. Now to verify whether the factors are correct, what I will do, I will just take n and I will multiply this 17, which is first factor, and 23, which is second factor, and see what is the answer. If I calculate 17 into 23, I get the answer as 391, which is nothing but my n. That means the two factors which I have calculated are correct factors. Okay, so therefore we have to write down, therefore factors of 391 are 17 and 23. Okay, so this is nothing but your final answer, okay, for your number 391. Okay, so this way you have to solve the problem. I will just quickly revise the problem so that you understand what we have done. Okay, so while doing revision, I will just take an example. So same example. So I initially step number 1, what do I do? In my step number 1, I take A value as 2. Okay, and in my step number 1, I take the A value as 2 and E value as 2, as it is given to us. Okay, and then what we do in step number 2, we will continue the iterations, all this iteration until this condition is satisfied. So in this iteration, we will go from E value 2 less than 8, then so first way 2 less than 8, or we will calculate, then we will calculate the value A and E, then 3 less than 8, okay, 4 less than 8, then we go for 5 less than 8, 6 less than 8, 7 less than 8, okay, and 8 less than equal to 8. So while doing this, you require a lot of calculations, you require a modular exponentiation to be done, okay, so to calculate the value of A. So now once you get the value of A, what you are doing, once you get the value of A, my step number 3 is to calculate what is the value of P. Okay, to calculate what is the value of P, what do we do? I find out the GCD of A minus 1 comma n. Okay, once I calculate the GCD, I am getting the GCD as 17, which is one of the factor of your number 391. It is also a prime number. It is also a prime factor. We don't say as prime number, we will say it as a prime factor. Once I got my first factor, I can easily calculate what is my second factor. So my second factor is nothing but 23. Multiply 17 into 23 and check whether you are getting answer as n, that is nothing but 391. Therefore the factors of 391 are nothing but 17 and 23. Okay. So you have to solve more and more problems. In many of the paper, polar P minus 1 factorization algorithm problem have been asked. So I will give you straightforward one more problem. Okay, straightforward one more problem for homework, which will be included in your next tutorial. Okay, so your homework problem will be nothing but I'm giving you n value as 299, okay, and b value as 5. You need to find out the factors of 299 with one value as 5 using polar P-1 algorithm. Okay, if you are done with successfully, I will give you a bigger number of n. So let me know after solving whether you get the answer of 299 and b as 5, and I will give you another problem. Okay, so that's all for this session. In the next session we are going to learn third method of factoring, which is a very complex and lengthy method. I won't say it as complex, but it's a lengthy method, okay, called as quadratic sieve. Okay, so we are going to use quadratic sieve. After quadratic sieve we are going to learn what is discrete logarithm, okay, how to calculate a discrete logarithm of a number, okay, because we need this discrete logarithm for Poling-Hellman algorithm. Okay, so we need this for a Poling-Hellman algorithm. So we will solve that in the next session. So that's all for this session. Thank you.